We want to evaluate this integral, and we are going to use parts. Now, which of these functions is going to play the role of u? Well, typically it's the one that would eventually die. For instance, if I take the derivative of e to the negative x, it's just going to be e to the negative x all over, right? On and on and on and on, sometimes positive, sometimes negative because of the chain rule. However, the derivative of this would become 3x squared, and then 6x, and then like 6, and then 0. So this function eventually, quote-unquote, dies. So the one that expires, or the one that dies, that's the one that I'll let play the role of u. As a result, e to the negative x would be dv, and then its integral would be negative e to the negative x. And the other side, the derivative of this would be that. Now we know that for parts, we have to use this setup, uv minus integral v du. So let's dive into this. So I set up here, so this is u times v, right? So I'm following the green. So u times v would produce this first term there. But then it says minus. So here's my minus. Here's my integral right there. And then for v du, I go v times du, and that's this stuff here. What happened from here to here? I did a little bit of cleaning. I took out the negative negative as positive. I took the 3, dumped it outside. Now, note that for this integral here, I have to do another setup of parts with these specific roles. So what's going to happen now, by substitution, what would replace the integral inside of the parentheses? Well, uv minus integral v du for these values here. We could do a little bit of cleaning up. And then yet again, a third time, we will probably need a parts for this orange stuff there. So let's do parts yet again. And just continue with this. We can make substitutions here. Right, again, what would replace the orange stuff? What would go in the parentheses? Well, whatever uv minus integral v du would give us. That would be this here. We can do a little bit of algebra. And then essentially we do one more integral, this here. And then this would give us our finished result. I do want to make one quick comment. This process, it's kind of messy, but it's correct. And this is our final answer. But there's this method that it's called the tabular method, and it would give you the same conclusion, but I think the tabular method is a little faster than all of this. It's a little faster. I was not shown the tabular method. I was just shown this way here, but it's a good thing to look into. Look into the tabular method and how it works, because it gives you this final answer, but in a more efficient manner. So I'll just throw that comment out there.